All right, class, so we're going to be starting looking at applications of solving. So far in this unit, we've covered changing between the different forms of a quadratic relation, and then we move on to all of the Max-Min applications of quadratic relations. And then we've covered all of the different methods of solving quadratic equations, and now we're going to move on to application problems where you have to solve quadratic equations. So we're going to spend a few days on this. And again, just like with the Max-Min application problems, there are several types that we're going to cover. So the first type, just like with the Max-Min problems, are the ones where the equation is given. So for example, a rocket is launched from the edge of a cliff and its height, represented by h in meters, after t seconds is given by the equation. So height equals to negative 5t squared plus 40t plus 70. So part A asks us how high is the cliff. So the rocket is launched from the edge of the cliff. So pretty much we're looking at the initial height of the rocket. Okay, because if I draw a graph, so this is height and time. You're going to start off at the rocket is going to start off at some height, which is the height of the cliff. It's going to be launched. We know the parabola is going to open down, so it's going to look something like this. Okay, so if we want to figure out the height of the cliff, we have to figure out the initial height of the rocket. So in this case, for initial height, the starting height is the y-intercept. So this is where t equals to 0. So all we have to do is we'll sub in t equals to 0 into the equation. Now I didn't leave much space for us to show the work here because if we sub 0 into the t, we know that we're just going to end up with 70 meters. Okay, so that is the initial height of the rocket and the height of the cliff. So part B asks us for the maximum height of the rocket. So going back to the Max-Min application problems, if it asks us for maximum, then we know we need the equation or in this case, this is a relation. Cross that out. We need a relation in vertex form. But the equation or the relation that's given to us is in standard form. So if you want to go from standard to vertex, that means we have to complete the square. Okay, so let's complete the square. Put the first two terms. A is negative 5. Take b divided by 2 square. Take your negative, we should multiply by a, and then we end up with, in vertex form, h equals to negative 5 t minus squared. This is 80 plus 70. That's 150. Okay, so that's the equation in vertex form. And from the equation, we can get the maximum height, which is 150 meters. So this type of question we covered in the Max-Min application problems earlier in the unit. So now for part C, it's asking us when was the rocket at a height of 100 meters and round the answer to 2 decimal places. So it's asking us when, so we're looking for time. If we use the equation, that means we need to know what height is. So it does tell us the height is 100 meters. So we know that the height is 100 meters. We have to look for the time. So I'm going to use the equation that's given. I'm going to sub in 100 into the height, and I'm going to solve for time. Okay, so let me sub it in first. 100 equals to negative 5t squared plus 40t plus 70. So I only have one variable left, which is t, so we can solve for it. Now we learned 3 different methods of solving: factoring, rearranging a quadratic formula. Before we even begin to solve, we have to make sure that it's set to 0. So I'm just going to move the 100 over, and I'll end up with this equation here. Now, since it tells us we have to round our answer to 2 decimal places, what I would assume is now factorable, so we'll use the quadratic formula. Since it's in standard form, so again, it's in standard form, so we either use factoring quadratic formula. Since it says round answer to decimal places, I'm assuming that it cannot be factored, so now I'm just going to use the quadratic formula to solve. In this case, we're solving for t. Okay, sub everything in. I'm going to calculate the square root, what's inside the square root first. Gives me 1,000. Okay, we know we'll get 2 possible answers because of the plus minus. And because this is an application question, we have to change it to a decimal. In this case, we rounded to 2 decimal places. get 0.84. And 7.16. Okay, so there are two possible answers. If we look back at the sketch of the graph that I did for part A, the question asks us when was the rocket ahead of 100. So let's say 100 is somewhere up here. That means the rocket reached 100 meters when it's going up. That was at 0.84 seconds. And then again, it reaches 100 meters when it's going down, and that's at 7.16 seconds. And that's why you get two possible answers. Concluding statement. That's 0.84 seconds. So just make sure you're not getting confused with completing the square and solving. The easiest way to distinguish between the questions is if it's asking for you for max or min, then you know you need it in vertex form. And that's when you have to complete the square. Whereas if it doesn't tell about max min and you're solving for one of the variables, that's when you use one of the methods, either factoring, rearranging, or quadratic formula to solve for the unknown variable. All right, so moving on. So this is a type of problem where you're given the equation. Next, we'll move on to a problem dealing with number relationships. So in this case, for this question, the sum of the squares of two consecutive integers is 841. What are the integers? Okay, so we know consecutive just means the numbers are one after the other. So we have two consecutive integers. If we square them and add them together, it's going to give us 841, and we have to find what those numbers are. It's not asking us for max or min, so we know we're solving. So let me write the let statements. Let x represent the first number. If x is the first number, that means the next consecutive number would just be 1 after, so x plus 1. And the x plus 1 represents the second number. And then we come up with the equation. So if we square the two integers, so if we square the first number, it will be x squared. If we square the second number, it will be, make sure you put brackets around it, all of x plus 1 squared. It's telling us that if we square the two consecutive integers and we add them together, so the sum of the squares of the two consecutive integers, it would equal to 841. And that's your equation. Okay, now let's solve. So this is not in any form that we know. So what we need to do is we need to FOIL this, because this is just x plus 1 times x plus 1. Move this over, so it's set to 0, and then we simplify to standard form. And then we can either factor it or use quadratic formula. So I'll write this as x plus 1 times x plus 1. FOIL. Okay, simplify this. And I'll move this over. And then your final equation will be 2x squared plus 2x minus 840. Now we know we're going to get whole numbers in the end, so that means the equations are the equation is factorable. But because, well, we can always factor out the GCF, which is 2, but then we'll still end up with a pretty big number. It'll be 420. So if you want, you can always use quadratic formula. So I'm just going to use quadratic formula. Plug in everything, and then figure out the square root. Uh, 6,724. Before we do that, let me take a look. Square root of 6,724 is 82. Okay, we get two possible numbers. If it's plus 82, that means is 80 divided by 4 is 20. If it's minus 82, it'll be negative 84 divided by 4, which is negative 21. But wait a minute, they're not consecutive. What we found here was x. And x is the first number, so we actually get two first numbers. So you have two sets of consecutive integers. So the numbers are either, so if 20 is your first number, then that means your second number is just 21. Okay. Or, if your first number is negative 21, that means your second number, if you add 1, will just be negative 20. That's it. Just be careful that when you get two possible answers, make sure you look back at your last statement, especially with number problems, making sure that you find the second number as well, because these are just the first numbers. So you get two sets of integers. For today's, we're on day 11. So hopefully I'll be able to cover all of this lesson. I'm trying to have it within half an hour because you guys have half an hour for the quiz. So just work on day 11's work after the lesson, and then we'll move on to the other types of application problems on Monday. Okay. So the other type that we're going to cover today is revenue. So we know how to set the equations up from the maximum application problems. So it's similar when we're solving. Okay, so let's take a look at this one. So Denver and Hudson have decided to be entrepreneurs and open a business that sells headphones to students whose teachers have confiscated them for listening to music during class. Last year, they sold 300 headphones for $20 each. They hired a marketing company to do some research for them. The research indicated that for every $5 increase in price, there will be a drop of 30 sales. What should the selling price be to maximize revenue? And what is the maximum revenue? So the first part, it's asking us for the selling price as well as the maximum revenue. Since we're maximizing revenue, that means we know that we have to find the equation in vertex form. So then we have to complete the square. So this is what we did with the maximum applications for revenue. So when we set up the equation again, revenue. So this, in this case, is the number of headphone sales and then the price per headphone. So in this case, when they sell 300 headphones, it's $20 each. And if they increase the price by $5, there will be a drop. Make sure you write your let statement. I'll let X represent the number of time prices increased. $5. It's the same way we set up before, the same way to find the maximum revenue. So we set the equation, now we FOIL to get the standard form, and then we're going to complete the square to get it to vertex form. Okay. We're going to rearrange and then collect the like terms at the same time. This is what we did before. Okay, so we got into standard form and now complete the square. A is 150. Okay, so we got the equation in vertex form. From here, we know the maximum revenue is just $7,350. To get the price, so maximum revenue is $7,350. For the price, we know that it's 20 plus 5x, and x in this case we get 3, so just plug that in to the x. 20 plus 15 is $35. This is the same thing as what we did. This was for the maximum application for revenue. It's the same thing. Okay, you saw one similar on your quiz. Okay, so on to the solving. It's asking us what the selling price, what would the selling price need to be to achieve a revenue for $6,750. So we need to find the selling price again. So if we want to find the selling price, we need to know what x is. So we have to find x. And what else? What's given? It tells us that the revenue is $750. So we have to find the price that would give a revenue of that much. It doesn't mention anything about maximum here, so we're not solving. We're not completing the square. Okay, so this time we're solving. So when we solve, we can choose, I would choose the equation in standard form to solve, or you can use the one for vertex form. Right, so from part A, we know the relationship between the equation for revenue is R equals to negative 150x squared plus 900x plus 6,000. That's from part A. Again, you can always pick the one in vertex form as well to solve, but I just pick the one in standard form. So I know revenue is $6,750. So I'm subbing in this into R, and then I'm going to solve for x. I'm just going to use quadratic formula again. Okay, so make sure your equation is set to 0 for us to solve. Move the 6,750 over, and that makes the equation become this. And then use quadratic formula to find x. I think it was a pretty big number. Let's see what that is. Probably typed in something wrong. Let me check the code again. $360,000 is what I got. And that does give us a nice number. Square root of that is 600. So 2 possible values for x. This is negative 300, okay? 1. Negative 15, 5. 1 or 5. So there's 2 selling price that would give a revenue of $6,750. You got 2 possible values for x. That means we're going to get 2 different selling prices. So price we know is 20 plus 5x. That's from part A. So if x is 1, it's $25, or if x is 5, it's going to be $45. So these 2 prices will give a revenue of $6,750. It ran over by 3 minutes. Hopefully we're able to cover this all. So after today's lesson, work on day 11's homework. If you didn't get all of the lesson, as usual, I'll upload the complete lesson on Google Classroom. And what I'll do as well is I'll provide the link to the video as well on Google Classroom. And that'll be it for today.